the table, and then nicely you type out. Alright, type out. Whether words or Excel, right? Proper one or proper one. Okay, who else still haven't given the value? This is the process.
Sorry. So for the packaging 16, 10 and 20, we don't need to times, is it?
Yes, because 0.25 times 16.
Oh,
The
still
load
need the
factor.
times. 0.25 times 16. Okay.
So this is a load factor, right? So this one given, so you have to final value you have to type, you have to multiply.
Okay.
For those who still cannot get the range, I hope you can do the calculation again. My worry is if let's say you select the wrong compressor, it will impact even until project B because of the size. You know what happened, right? Later on when we want to calculate the size of the air receiver, eventually what we are going to do, if I say the size you calculate wrongly today, later on we want to design a compressor, right? Sorry, the air receiver like that. It means this is the receiver, the size. Alright, then we have the two ends, the sinusoidal end. So it becomes air receiver, right? So if you, let's say your size today, you select the wrong compressor, what happens is the pressure, the volume also will be wrong, right? Okay, so you select a wrong sheet of metal to form your receiver. You know, so end of the day we want to weld the receiver, right? Welding, do welding, such that we are able to design air receiver from scratch. So today important, for those who cannot get 240 to 250, right? I hope you calculate one more time, just to make sure you don't do mistake. End of the day will be easy for you.
249.1.
249, okay.
Oh.
Because I think
Who else are still
then you put the
calculating?
plus 30, right? Yeah, minus 30, minus 40.
Okay, so for those completed, now we come to the
Okay or
form.
not?
Alright? Okay, so just now we mentioned about this one 350, right? Diameter. And then this part minus 80, right?
Should be quite right.
And then the stroke. Alright, the stroke here. 665, right? So we are going to talk about the volume. So volume means what? Area times height, right?
Yeah.
Now the volume is area times height, right? So this is our height, right? And then this is our area. So what is the formula of area? Right, R square, right? Or can also talk about this one will be
Pi over 4 pi square.
yeah. So diameters, right? Equal to Okay. So this one will be the upstroke. Upstroke volume is higher because of the diameter 350, and then downstroke we have to minus 50 mm, right? Right. So 6 stroke up, 6 stroke down in 1 minute, correct? Okay, so 1 minute, what is the total volume, the air generated by this piston? So you know, right, how to calculate this volume. Alright. So after that, because in order for this force to work, right, air pressure inside is 590 kilopascal each, right, given. So later on, you have to count the free air because over here they show us. Alright, the force the requirement is free air unit. Free air unit. So this is the pressure. Alright, so we talk about using formula P1 V1 over P2 V2. Alright, so right now what we have here, free air at 590 kPa plus 101 air pressure at 0.3 kPa over 1. And times the volume, just now you calculate. Then you get the free air value. Okay.
How do you get 101?
This is the air pressure, our normal air pressure.
Oh, atmospheric.
Atmospheric pressure. Alright, because we are going to get free air, right? The requirement is free air. So that's atmospheric pressure. 590 is the gauge pressure for your force. Okay, so for those who completed the normal the tools requirement, now you proceed with this, the force volume.
You only say to pay one volume. Oh.
Value 1 can find volume. If I'm not wrong, it's like that.
So now we are finding volume 2.
No, we got volume 1 and volume 2 already, right?
Yeah.
So we can find P2.
No, P2 we don't need because P2 is atmospheric. So it's definitely 101.2. Because atmospheric is fixed on. So I think now he want us to find is V2. So if let's say we find we use our V1, right, then we use this formula to find we should get V2. But I don't think we will.
What is V2? V2 is
The volume at the other side. Just
So this is the volume square. Then 51. Rest of all
Yeah, so our track volume is okay lah, pressure quite slow.
Actually, was
Previously, I mean it was correct lah, the extend one.
the usable area?
The usable area previously was 3 something, now it's 30. 308.
Is the bigger diameter minus the
Oh, you forgot to times high, I think.
the big minus small, right?
Yeah.
50.
350, yeah.
Minus 80 small diameter, correct? So pi r square pi
meter cube, yes. Meter cube per second. But this one, right? This is in liter per second, right? Our right liter per second for our normal workshop. Okay, so now you calculate this out, right? It's in meter cube, right?
Yeah.
So you have to convert to liter per second. Because this is minute, right? In minute, so you have to calculate liter per second. No, 80 is this area.
Oh, okay.
Yeah, you see what happened is the ball, right? The surface is bigger area, right? Bigger surface area, 350. If you look at the piston design, right? If let's say I show you.
Actually, you should get the same answer. I mean, you should get the same as the corner. Check. Oh, you finding P2?
Different Pile square. Yeah, I think the cylinder is the same as the rod, right? Yeah, so the piston is usually the same as the rod, usually.
Okay, the rod usually should be longer than the cylinder. I mean, else the cylinder will go.
Usually, I think that it's usually complicated. I mean,
Oh, yeah.
the diesel piston is not. And then you see P2 is free air.
Let me see.
Okay, so you see, right, the design of the piston is like this. Alright? So this is our surface area, 350 mm, right? Upstroke. Downstroke, well, you can see the area here is actually, there's a thickness include, right? You see the thickness, so yeah, this is thickness 40 mm together, 50 mm, right? So now the air volume is actually within this, right, within this diameter, correct? Smaller than this one there's no, right? So upstroke, your diameter is 350 mm. Downstroke will be lesser. Why? Because of the thickness of your cylinder, right? 40 mm, 40 mm. So
Oh, so we need to deduct away.
correct.
Ah,
So the
okay.
downstroke you deduct away 50 mm, your diameter. Because this is double acting piston, right? Double acting this up and down also generates pressurized air. Okay now.
Oh yeah, then that's how you want correct. You want
If okay, right? 6 upstroke, 6 downstroke. 1 minute, 12 stroke. You add up.
Right.
Yeah, correct.
And because of this is a meter cube per minute,
Maybe this one also.
you add up, right? So it's a meter cube per minute. You have to convert to liters per second. Now convert to liters per second. Because why? Because others, alright, tools used are in unit, like in liter per second.
Sorry. But just now you mentioned about the minus 81, right? But if you use this formula, you find the area, I mean the volume for the volume 1, right? You actually don't need to even do the deduction. You can just use this formula to get volume 2, right?
Yeah, but you see, the upstroke, your surface is 350 mm, right?
Yeah, correct.
Downstroke is not 350, my downstroke is this.
Oh,
Right? Downstroke because you have to minus 50 mm away. Because the diameter is shorter.
why are you trying to find? Are you trying to find P2 or V2? Are you trying to find P2 or V2?
Oh no, this one is the piston, but this one P1, P2 is the atmospheric pressure.
So P is
You got to find
everywhere.
free air, right? Because later on, let's say your P1 is your 590 plus 101.
Yeah.
So the P1 is atmospheric.
Then
Atmospheric.
after that, V1 is your calculated volume.
Right.
Yes. Okay. Correct lah tadi.
Upstroke ball, upstroke. Yeah, because this upstroke is this. But actually no difference because the add up is the same.
So I think the V2 maybe is the volume of the air outside of the cylinder.
Okay, so over here your V1, V1 is your after you calculate right the volume, right? So this is a V1. As you know, right, more pressure means what? Less volume, right?
Yeah,
Then if let's say based on atmospheric pressure, so volume will be
bigger.
right?
Yeah. Oh, so this V2 is actually not the other side of the cylinder, it's actually outside of the cylinder. Is it?
Yeah. Free air lah, free air.
Okay.
Because right now it's inside the cylinder, right?
Okay, so V2. Here we are calculating free air, right? So V2 is the volume of free air for the upstroke. I believe lah. Somewhat, yes. So we actually also need this volume to find the other side.
Find V2 ah.
Yeah.
Point three ah. $259 times. That's about All of them are KPA. Why? All of them are KPA. How are they? B is right? Package can be better. Package is like a Pascal for this.
I think it's like, what do you get? I think the air, free air should be 49 liter. I think 38 is the retract volume, right?
Yes.
So need to find the V2. V2 is the atmospheric free air volume for
Alright. So this
the
one.
downstroke.
This is P1, right?
Yeah.
This is P1 for quick. P1 is 5 plus 101.3 times
101.3.
right, times the volume, the cylinder volume,
Yeah.
the rod, so the minus one,
Yeah, correct.
correct?
Yeah.
Equals to the atmospheric pressure is 101.3 times V2.
Yeah, correct, correct.
So this one is
Okay,
one step
okay.
bring down over.
If my V2 I get 183, I think maybe I count that. Let's just find 117 minus. My V2 is 18. 175. Yeah, correct.
Yours is
Same thing, yeah.
380.
387, correct. Maybe why maybe my calculation wrong. If minus, if plus, yeah. My one I put minus everywhere. Correct. I think you calculate this one also. The free air volume for the downstroke and the 6 stroke.
Oh, is it? You can show this screenshot. Oh, I really did a picture.
No, that one is just times 6. This one times 6. Then the other there's one upstroke also, right? The upstroke is okay. No, but you still need to.
This is the upstroke.
Okay.
Correct?
This is the downstroke.
This is the bigger one. This is the left one.
This one is the less one, right?
The left one, yeah, the left.
Yeah, this one is the less.
This is the right.
Then one you just write V2 for this one equals to 2. Equals to 4366. V2 4366. 21107. Then you just write maybe this one upstroke or something. Then the other one is downstroke. This one upstroke. Then this one is downstroke. This one is downstroke. Yeah, this two is V2. This is V2 for the downstroke. This is V2 for the upstroke. So this is like the free air V2.
Free air version.
Yeah, free air version. So you need to this one times 6, this one times 6. So it's this one is 1559 004673. And this one is 2619 726645.
Okay, so
266.
just to clarify, okay, so my apology. The rod diameter is 80 mm. So they call it as 80 mm. So what happened is 350 minus 80, right?
Yeah.
You get 270 lah. For the downstroke. For the downstroke. Okay now. So according to this alright, so that means this is diameter of your rod. Okay, occupying 350 minus 80. Alright, so your downstroke, the volume will be lesser. Alright, so please calculate again. Means what happened is this, right? I wipe out this one.
That's right.
Alright.
Yeah, also.
Confusing as well.
Alright, so means your upstroke will be alright by so your high right, your stroke is your high right. Alright, then your downstroke alright. After that, times 6 because of 6 stroke. Up 6 stroke, down 6 stroke per minute.
Okay.
And because surface area we use is in metric, right? Metric, huh? So the meter cube per minute, right?
Yeah.
Convert to meter per second. Because to follow, alright, the rest of the tools. So please do the calculation again.
So around 69.6, is it okay? Liter per second.
69.6.
Yeah, liter per second.
You really times 6.
Yeah. That time, yeah, times 6 already. So yeah, this one is the ball pi over 4 times the ball
250.
square times the height of the stroke. Then this one is the V2, which is the atmospheric upstroke, which is the pressure 1 minus plus
590
pressure
plus,
2
okay.
divided by pressure 2 times the volume.
So your volume is not correct.
Volume is not correct. No, this one is the upstroke. Right? Volume is not correct. Yeah, that's right.
Yours is valid.
I feel it's correct. Unless my plus minus wrong.
You want to clear the atmospheric pressure. I know.
That's it.
Conversion, my computer calculated. I think I took the exam. The conversion is the tricky part.
Yeah, I mean, like if this MMM, you just stick to MMM. But this one MM cube, I remember it's just
6 about
yeah, about 6. Because I remember meter cube to liter is like times 1000. Maybe he converted to meter cube, that's why.
the volume 350 mm, right? So we convert to matrix 0.35, right? Right? So your small d is your 80 right mm. Right now. So if let's say you count, this is what we have, right? One stroke. After you get this times 6 will be your value. Okay now.
The volume of air times 6.
Yeah. Yeah, this one.
We follow this formula.
Volume of air times 6.
This
This
volume
is
of
one
air,
stroke
That means
up and
one
down.
volume minus
Consider
6
one
cycles.
cycle, right?
So it should be the same. 6 cycles.
No, this is upstroke. This is up or down?
Down. The D minus, big D minus small d is downstroke.
Then we don't need to care about V2.
Oh, sorry, 2D.
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 Because we say initially, upstroke is what? Upstroke. Alright, so the downstroke is this.
My textbook is easier. I got this textbook. Sure, computer.
Alright. Okay, so you add up these two, right? You will get this.
Oh, you need to add up.
So please recalculate this again.
You can make a new one, they can compare.
So I just don't change all these.
Interesting to see how it
Go 4 times d square d square
no minus. You plus the stroke. The 18 is stroke every day.
Oh, I think my all the formula shift down, so should be. Yeah, never mind, just. Big D minus small. This
No paper, no paper.
no, it's just this mouse the sensitivity. Okay, so this.
Is that correct? Is that correct?
4 times stroke, more square times stroke, 17.
Okay.
This one goes to this times 6. This is meter cube. Meter cube. So less man. Oh, I think divide by 60. Even less.
Too many questions.
Then only one stroke, 6 strokes. How down
6
6
times
strokes?
6 cycles. You do 6 times. It's correct. No, it's 6 cycles.
So it's times 6 divided by 60. 0.12. Divided by 6 stroke is in 1 minute. 6 stroke in 1 minute. So divided by 60 seconds. So it's
For the
this one per second. Maybe is it times 1,000?
Okay,
Or
so for this one, about 12 liter per second. Anyone don't get 12 liter per second?
12.46.
Sorry, 12.46.
Oh, then correct.
12.46, no problem. Anyone don't get 12.46? Anyone don't have 12.46?
So from meter cube per second to liter per second is times 1,000.
So convert, initially is meter cube per minute, right? Then convert to 12.46 liter per second.
Times, yeah, this is times 6. Oh, this is per minute. Yeah, now we do.
pressure thing come out. I don't understand. Why the pressure come out?
Don't even need pressure.
Then what does this got to do with the pressure?
Okay, so now you need to find the free air. Alright?
Isn't this the free air?
This is the gauge because from the piston, right? So now you need to find free air volume.
Okay, so it's V2 lah. This is V1 lah.
Yes, so now you have to find this is a V1, right?
Oh, okay.
This is a V1. Now you need to find V2. So this is the formula you apply.
Almost there.
Okay, yeah.
Alright.
85 ah.
So now your volume is here.
V2, V1.
12.4. So what do you get here?
85.04.
How much?
85.04.
Okay, so 85 acceptable, huh? 85, and I think 85.
A lot of V2. V2 is atmospheric.
This one is in the piston, right? Now we want the free air, means what? Atmospheric pressure. Less pressure means what?
Less pressure means
More
more
volume,
volume.
right? Because air atmospheric pressure compared to 590 kPa is actually lower pressure. Lower pressure means more volume, right? Correct. Alright. So with this, now we know.
V1 is so messy.
Yeah, very messy. But I think I just read this. This one that means he's wrong.
So now you have to plot the graph. Alright, so this is meter per second. What will be your normal operating rate? Just now you mentioned, right? About 242, some 246, some 248, right? Correct? This one without the force, correct? Alright, so over here we have for the first minute your force is on, right? So means what? Means force on. Right? So this is your first minute. This is your 5th minute. Then again a cycle. So say we talk about 30 minutes here. Your question asked is 30 minutes. Alright. So you can see right now this is the peak value with the force on, correct? And this one is average without the force. Right? So according to our course note, what's important is we want to select the compressor based on the average. So what will be the average? You have to count out. Right, you calculate your average. Then the next step will be compressor. We want to select compressor that can meet this demand. Okay? So compressor, according to our course notes,
But runs for how long? How long? 1 minute?
30 minutes. Total rate is 30 minutes. So
not half. This is 1 minute. This is the fourth minute. Without the so we are talking about 30 minutes. Right? So we are talking about
I think 1 is enough. Works very buggy. Works very buggy. Like once you put everything, like then you shift everything to one. All the alignment, everything.
the pictures are
Yeah.
So I think I can do that now. I can do the then you draft it out. That means the peak is this peak is included
This
cylinder.
yeah, this peak is this 429.1 plus 85. So this should be normal, I think.
So really 85.
Yeah. Thick is 85 plus this.
You want free air, right? So 350. Average. I think this is good.
Actually, average just equals this. Equals
Interval 4 minutes.
but that can just average. This average formula is just take this one.
For 5 minutes.
Yeah, like how many oh yeah, 5 minutes oh. Yeah, I think I cannot. I think I cannot. Yeah.
I can draw something. Yeah.
1, 2, 3, 4, 5. Oh, actually, we can do this. Zero minus zero plus
Now you just need to calculate for the because this is with the fork that is considered a big one. Then after that 4 minutes without fork, so it's a normal. Next cycle another 4 minutes. So now you want to find out the average.
But this called
You can end something.
Yeah, because so you add up everything. You add up
End function.
the area here, right? Now it's the area here, right?
30 minutes, right?
Right? Then after that you divide by 30 minutes. Then you get the average result.
So if you find the average for the first 5 minutes, you find the average for 30 minutes.
This is times 5.
5 minutes. That's 5 minutes.
Your formula for the P1, V1,
Because second, this is 1 liter per second.
why
Right?
you added 1?
yeah, it's liter per second.
So because we're talking
You say
about
find the first minute first, which is the maximum.
Okay.
Alright, so whatever inside your piston, right, is 590
It's also the 335.
So now,
4.1.
yeah, now after that, the reference to the fuel volume is 101 point.
Yeah, 1 minute, 60 seconds.
So it has to be added to the 5 minutes.
This one is
249.
60.
I mean, I can just like that.
Okay, later I check for you.
266.
Yeah, quick, just now V2 right? Now just now it's 5. Yeah, then my V1 so together with your just now
60 seconds.
For 4 minutes. Why you done 60?
This is meter per second.
Yeah.
Because you go convert to minutes. It's minutes, right? Because you're very on 30 minutes. Right. So this is so for 590 plus 4 plus 3.
But this one's atmospheric pressure.
So you can use as a
Because this is a pitch pressure.
so this divided by
Ratio. So 590 plus
5 minutes. You repeat this 5 times. So 5, 6 times.
Yeah, correct.
pressure is
You're finding like average liter per second. So actually you don't need to convert the unit because oh then you convert
I mean, this is 12.6. So this is your 0.6. This one is second.
It says that it's for 30 minutes. Just for 30 minutes.
Per second we probably cannot exceed the peak also. We've got to get average because average should be in between these numbers. Your average should be between these numbers. So should be 266. What's this graph mean?
So normal will just be the one.
Well, after that you must find average. Average will be the one determining your compressor Okay, so this is 12 minutes without the formula. So this one fixed means that's the defined. So I get what 6.5.
I think I can draw this graph using bar chart.
No, this one is the now the rules that you calculated. Alright. Average. Because we talk about you take 5 minutes, 10 minutes, so 5 minutes is like
I think can use it here.
first minute you are forced on. So it's considered as big demand from the top.
So I think we just need to overlap this thing, then we can see we can become like that. So I put 0. Oh?
The line graph average.
Then we just put this sticker. Put this sticker.
Then now one more line.
Which line?
For average.
Oh, yeah. Secondary.
You can find out 3 feet.
I should use combo graph instead.
Is it your average? I think
Sorry.
Which color one can get? This is a bit.
Okay, so what is the average? Okay, 265 acceptable. Who else?
266.
266 acceptable.
Horizontal. I need to figure out slowly. Sure, right?
I think everybody so you bring down. Have you ever said that?
No, but this one is series 1 and series 1, so every should be the other one. Cannot, you're put into the last bit. We must separate the. Oh, I forgot how to put the secondary
Okay, who else cannot get average to about 265 or 255 acceptable, 255.
Never mind, I go back and research. I forgot how to do it.
Your first minute, right, 240
Don't you do like your first?
Secondary one. I got combo already, so I think we can add the.
So this one plus this one 4 divided by 2 divide by 5
which shows the average temperature cylinder. What I want to do next is to add the average rainfall data to the same data. On the left side where it says
Anyone cannot get 260 something?
I know I can do. I mean, this is like page 3 lah. I can do this. And I just draw 2 lines. I can combo this. Stable.
So you define average means
The series name, they can simply use data. On the left side, right name, I check the entries. When you cut, for the series name, I can simply select. So let's then for the series values, this will be the cell.
Secondary axis.
So,
You need to be primary.
then what you
Gradient line, transparency, maybe transparency. At most we just hide this column.
So I need to put in the document, no screenshot only.
But I mean we can just hide this. Then we copy this, we put the average here, then we just screenshot, then we just copy this graph. And this one we can put in minutes. And this one, I just rename this. Then we don't.
Period.
Actually this one don't need to show, just show like that.
No, okay, orange I can show. You can label orange. Orange is consumption period. Consumption period.
Oh shit.
Bracket minute. Or usage, then bracket minute.
Oh, usage, oh yeah. Yeah, usage now.
Bracket minute.
No need, we just put like that, right? Then at this axis, right? Then we can add oh yeah, here, then just liter per second.
Doesn't really tally, no? Liter per second. Then minute. Feels very weird. Second, here then minute.
No, because air usage, right, usually is 5 per second.
Cycle.
Here I can put like the grid line.
Okay, class, I believe most of you get the average about 2.6 plus. Consider okay. Anyone still don't get 2.6 plus something for the average? So this is what we are going to do, because today we know that the demand from the workshop, alright, average about 248 liter per second, because without the force. Alright, all the tools are included plus the leakage about 24 something. For those who cannot get 24 something, I hope you can go back, try to go through again. Right? After that, with the force is 85, something like that, right? 85 something liter per second. You add up, is considered our peak. So what we are going to do, this is a compressor. Alright, we are going to select based on your average value. And in order to cater for the peak or surge of the demand, we have reservoirs. Alright. So today when we go back, you refer to your notes, and there will be activity, right? Activity will refer you to a list of compressor. Alright, list of compressor, you must find the one that is close to your this 265 liter per second. But the compressor listing, right, they actually use meter cube per minute. Yeah, so 265, alright, liter per second, you convert back to meter cube per minute. What's your value?
Which one activity? What? Sorry, it's activity. What activity again?
The activity from our this
But there is activity 1A, 1B, 1F.
that's what I want to find because
Share
I couldn't
material.
remember which activity actually have the listing of the compressor. But when you go back, when you revise that, there will be activity that actually show you, okay, the selection of the compressor list.
Cannot be go through all the
Okay. Alright. So again, you want to select a compressor very close to this. Higher cannot be lower than 15.9. I mean the average that you calculated cannot be less than your average. Must be higher, right? But not too high. Why? Because we are going to design a receiver such that we do not need to select the best compressor that actually waste money, right? We don't want you invest too much money, right? Too costly the compressor. We want to use the average one, meet our demand, but not every time meet the surge demand. We want to meet the average demand first, right? We build a reservoir in order to meet the peak demand. This is the whole idea of our project. Next week we will talk about the size of the cylinder or air receiver, right? But today you go back, select the compressor. Next week I want to see whether you select the right compressor.
Slides for the compressor. Can you ask the slides for the
cannot really find it. There's a lot of activity.
Okay, so give me some time to look for the compressor list because now I cannot find compressor list. Discover.
Finish now, I go home, I try to type.
I think I I try to find a OneDrive. Or is it? Then I share with you. Then we can go back then.
OneDrive.
Yeah. Like OneDrive. Then I just share with your email. Then I will try to upload this one.
Then you know this I never video about then he create.
Yeah.
I could try to. I only have OneDrive before. I don't know. Actually never used OneDrive before.
I also never really use. I only just started using 365. What's the Microsoft or Teams? Should we put in Teams?
Yes.
You got school team?
Huh?
You got school team?
Yeah.
Average about 30 minutes, am I right?
30 minutes, correct. But because you are using,
But I'll try to tidy this
5
one.
minutes I consider okay.
School team. You have a school.
Activity 2B.
SharePoint. Maybe a SharePoint. Okay, relax.
Holy shit.
Cannot go in anymore.
Your email. Your Wi-Fi team.
What's the
I will give you your email.
okay.
Alright, okay, now I found it. Under appendix 2A. Alright, okay, so right now, let us take a look, take a snapshot. If I say you cannot open, right? Take a snapshot here.
You can send in campus.
Okay, sure. I will update on the campus. Okay, so we are looking at this compressor, right? Alright, so which one do you think is more appropriate for our application? We talk about free air delivery, meter cube per minute. Just now we agreed,
Oh,
right?
sure.
Agreed, huh? Based on average
So I'm
demand,
talking of how to make it
which one more
work
appropriate?
this before right, your work this.
But I don't use this actually. Our work we don't use this. We use
Free air delivery. Stand for free air delivery. That's why we wanted to find out free air, right? All these is free air, right? Because of
Actually you can check also check the different power.
yeah, actually it's the same.
Alright, the reason why we want to find the free air, right? Because to select the compressor, we convert to free air. To find the compressor that meet our demand. So which one do you think more appropriate, huh? Depending on this. Very good, huh? Alright, so your selection very close to 16.3, right? Can meet the demand, huh? Anyone, if you don't get this, please go back, go through the two lists. Find the one very close to this.
Oh, your home is your workplace.
I can try to figure out a way.
So that you won't suffer later. Alright, you won't suffer later on, you get the wrong thing, deviate from the course. Okay, let's say everyone compressor, but the value will be different. I will mark according to the two lists. But your selection of the compressor is important because it affects the size of your reservoir.
So you're using two spades? You got uploaded the final one? The cube.
Oh, I haven't.
Okay, so now for those who selected the compressor, besides important things like free air delivery, alright, another one important is the coolant. We have an inner cooler inside the compressor that dissipating the heat generated by the friction because of the movement of the piston, right? Over here they talk about the coolant here, meter cube per hour. So what happens is this, right? The coolant is water, right?
You just send me the
The flow rate, right, 1 meter cube per hour, in order to dissipate, carry out the heat. So this one applicable when we do question 4, right? Your electroplating, right? Electroplating. Remember, you need to have hot water. We are going to use this later on when we come to other subsequent questions.
So you're choosing which one?
Sorry, so the coolant is
Later, choose now or choose later? The coolant choose now or choose later?
No, coolant is, let's say you selected the compressor, the coolant, all this is already determined. Because it's a design, the spec of your compressor.
then just now you mentioned about the hot water. The hot water is
Hot
go
water
through
is
to this
later on,
coolant.
the electroplating workshop.
So the hot water comes out from this after coolant.
So this one is a compressor. You also need to select after coolant. But this one probably next week we will try get this right.
Flow rate.
Okay, so the next thing is this. The efficiency of your compressor, right? Let's say right now, your free air delivery means this is your 16.3 meter cube per minute. This is your piston displacement. Just now we talk about this. Alright, your displacement is what? Over here they indicate what? 21.3 meter cube per minute, right? What is the efficiency of this? Because your displacement is 21.3, but your free air only delivered 16.3. So what will be the efficiency of this compressor? Alright, you can see if I say a full extension, supposed to be 21.3, right? But the output only 16.3. So what will be the efficiency of this compressor?
Drop
Roughly 76, right? Because of 16.3 and 21.3. Yeah, okay. You get your efficiency of your compressor. So you got time, right? Then, I mean, the question asks you, if you select other compressor, what will be the efficiency? At least you can explain, right? Which compressor actually most efficient? Definitely, if let's say you want to explain such that, okay, now I select DR4. Why? Because it will not meet the peak demand, right? But it's efficient. Why? Because cost efficient. Right, cost efficient. That's why I select. You must list out your reason why you want to select DR4. Although it's not most efficient, but it can actually meet the average demand. So for those cannot open this appendix, right? You take a snapshot. Alright, so this very close to what what we are discussing. And you can see how big is the compressor by dimension, right? The weight nearly 2 tons. 1980, the compressor that we select, nearly 2 tons. The length, this is 1.8 meter, right? The width 1.5 meter, the height 1.1 meter. Actually, it's a huge compressor.
But the dimensions for us, we don't need to care, right?
No need to care, but this is just to give you some idea. Some idea the thing that we do. Okay, so today what we do is so we select compressor, right? And this is after cooler. If you go to the appendix, appendix in this case.
What is 266? Oh, average is it? Yeah, average is 266. 16.
Appendix 2B, right? Appendix 2B, you have after cooler. So this after cooler straightforward. Why? Because they actually matching with this compressor. So which one? Let's say you select DR4, right? Which one will be the best selection for your after cooler? Okay, so over here, let's say we selected DR4. Over here, they show us this is the after cooler. That is actually appropriate for this group of compressor. Alright, can you see under DR4? Alright, so again, DR4 is here. And this is important in this part. So you see over here, right, very close, the airflow, the free air delivery, approximate meter cube per minute, right? If you go down to the DR4, the one that we want to select, 16.4, right? So it's very close to our this 16.3 compressor just now we actually selected. Then this is your flow rate, 1.7 meter cube per hour. Also quite close to our 1 hour, right? This one water consumption, right? Meter cube per hour, also very close up. 1.7, right? So this is an important value later we have to use, alright, to combine inner cooler and after cooler together in order to salvage the heat, alright, hot water, in order to send this water to the electroplating workshop. So you can take a snapshot if let's say you don't have, you cannot open up your activities. This one, please take a snapshot. Right. So we are using HD16 after cooler.
The heating up is as you can see it. You take snapshot to heating, you cannot see the heating.
Oh yeah,
Cannot see the heating.
Oh, cannot see anything.
Well, everybody can open the link.
Something wrong.
Yeah,
Probably have an update on the candle.
Yeah, you update on the camera side. The link open value.
Yeah, this one better, I think.
Report, is it report store?
yeah, you can see.
Listen to what?
Yes.
Just put
Okay. No problem with this. Okay, before we leave this classroom, I want to explain to you for next week. At least you prepare.
Can help facility manager.
yeah.
Do all this.
Okay, so next week when we come, we want to determine the size of the reservoir here. Alright? So imagine now we want to use this formula to find out
I put in the wrong.
our
I put in
the
the wrong
proper size of our air receiver.
Put the 13.
Right? We are using this
Put the
formula just to show you over here. Alright, so your
Oh, they put already.
compressor will keep supplying, alright, keep supplying air into the receiver. According to your project, they actually show this application. Okay, so we want to go through this, alright. Safety valve, this one later on we will find out the value in order to install the safety valve on the receiver itself. Over here, 790 kPa gauge pressure, alright. Compressor cycle off or cease to pump if pressure rises to this level. So the design is such that your receiver cannot exceed 790 kPa. If exceeds 790 kPa, automatically a compressor must off. Alright, so this is ideal. Alright, if let's say now the pressure in the tank or air receiver 690, compressor cycle on, or recommend to pump if pressure falls to this level. So in this case, when the receiver, the pressure is 690, your pump must run. Alright, over here 620, pressure in receiver should not fall below this level for proper functioning of tools. Why? Because just now we mentioned, right, only force alone need 590 already, right? Force alone, according to the requirement, 590 is needed for your force operation. Alright? And the leakage is what? 30, right? Just now? 30 liters per second. So you can see, you must remain 620 because the leakage is 30, right? So eventually 620 minus 30 is 590, sufficient for your force operation. Alright, so when we design, we have to follow this table accordingly. Alright, so what happens is your compressor must run 690. Alright, must run at 690. Okay, so we are using this formula. When you go back, try this out, right? Okay, so this is your receiver. Alright. So this is the time taken. Take it as 1 minute. Alright. So over here, P2, P1 means what? 690 kPa and 620, right? Your running of the compressor.
Yeah.
So these two very important. Why? Because first thing, your compressor must on. 690 kPa, right? Then after that, cannot go below what? Cannot go below 620. Alright. And then this is your atmospheric pressure. Okay, so this is your TS, 101.3 kPa. Right? And then this is a volume, alright, in and up into your receiver. Okay, so for those who want to go back and take a look at this, right, probably will take a snapshot. Alright, so we will discuss this next week. Just give you some ideas, overview, next week what we are going to do. Alright, we are going to find out the receiver size using this formula. This one you keep, next week you bring and then display again. At least I can address you. Now I don't know who you are, I cannot remember too many things. Alright, so any questions before we leave? Alright, good day. Okay, thank you.